Hi everyone, in today's lesson we're going to talk about factoring using greatest common factor and dots. So first I'm going to review GCF and then on the next page I'll review dots. So GCF, first we need to talk about what factors are. Factors are numbers or variables that multiply to another number or variable. So let's just practice making common factors. I actually don't like these examples that are on here, so I actually want to cross those off and start over with a different example. So let's just say I want to find the factors of 20 and 100. And I want to find the greatest common factor between them. Well, the first thing that we would do if we needed help finding the factors is we would go to the y equals in the calculator and put the number that we want the factors for and divide it by x. And then we would look at the table of values. So if you do that, feel free to pause the video at any time and type it in, and then hit resume when you're ready. So the factors of 20 are 1 and 20, 2 and 10, and 4 and 5. And now if I want to find the factors of 100, I'm going to do the same thing, go to the y equals, type in 100 divided by x, and then look at the table. So your values should be 1 and 100, 2 and 50, 4 and 25, 5 and 20, and 10 and 10. So obviously I see a bunch of common factors. I see 1, I see 20, I see 4, I see 5, I see 10. So technically there are a ton of those common factors. So I'm actually going to highlight all of them. We have 1 and 20, so 1 and 20. We have 2 and 10, so 2 and 10. And we have 4 and 5. So of these factors, we're actually looking for the largest number, the largest, greatest common factor, right? So it's clear that 20 is the common factor that's the largest. So if you needed to do all these steps to find the common factor, we could. There is actually another button in the calculator that will help us find the greatest common factor. It only works with two numbers though. So what you're going to do is you're going to hit math. You're going to scroll over to number, and you're going to go to choice 9, which is GCD. GCD stands for greatest common divisor, or in other words, greatest common factor. So you're going to go ahead and type in GCD, and you're going to put in 20, 100, and hit enter. By doing so, you should get 20. So that is the calculator way that we will find the greatest common factor quicker. However, the greatest common factor, that button on the calculator, doesn't work when we have variables. So what we're going to want to do for that is we're going to just want to write them down. So let's just say another example. We'll call this example number 2. I want to find the greatest common factor between x to the third and x to the 7th. The easiest way to find the greatest common factor is to just write them out. So x to the third just means x times x times x, right? X to the 7th means x multiplied 7 times. So 1, 2, 3, 4, 5, 6, and then 7. So if I want to find the greatest common factor between variables, all we're going to do is match up the x's. So notice how there's 3 x's here and 3 x's here. So that tells us that my greatest common factor is just x to the third. So whenever you're trying to find the greatest common factor between variables, just take the smallest exponent. So the smallest exponent is the GCF. And that'll help you when it comes time for variables. Okay, so let's get into some problems. Directions here say factor each expression completely. So I have 4x plus 4y. So if you need to find the greatest common factor, you can go ahead and use the calculator. Type in GCD of 4 and 4. Remember, the GCD only works for numbers, and it only works for 2 of them. So if you type that in, it's obvious the GCD should give you 4. So we do 4 is my greatest common factor, followed by an open parenthesis. That's the setup for GCF. And then we divide each piece by 4, that greatest common factor. So we divide the 4's here, we divide the 4's there, and all we're left with is x plus y. And that's it. That's the GCD. How about number 2? I have 14x plus 21x squared. So if you want to find the greatest common factor, go ahead and type that into the calculator. If you can do it in your head, that's even better. So we have the GCD of 14 and 21. You'll go ahead and type that in, and you should get 7. So we're going to divide each piece by 7, followed by an open parenthesis. But we should also keep in mind that we have variables. So we have an x and an x squared. So it kind of falls under the category here when trying to find a greatest common factor. So we say the greatest common factor between variables is the smallest exponent. So here's an x and an x squared. The smallest exponent is in fact an x. So we're actually going to take out not just a 7, but a 7x. And then we're going to divide each piece by 7x. So when we do over here, 14 divided by 7, we get 2. The x's cancel. And over here we have 21 divided by 7, which is 3. And then x squared divided by x, remember we keep the base, which is the x, and subtract the exponent when we're dividing. So 3x to the first. You don't need the first if you don't want it, but that is the final answer. All right, take a couple minutes and please try number 3 on your own, and then hit resume when you're ready for the answer. Okay, so you should have noticed that there's no number in common, but just a letter. So we're actually going to divide both pieces by x. So we have x on the outside, followed by an open parenthesis, and these divide out to 8, and then x squared divided by x, we keep the base and subtract the powers. So this should have been my final answer. Awesome. All right, how about number 4? Let's find the greatest common factor between the numbers first. So if you want to, again, type it into the calculator, you're going to do GCD of 8 and 4. Just check my math by pausing the video and trying it on your own. You should get 4. So we're going to take out a 4. Now let's focus on the variables. There is an x and an x. So it's obvious that I could divide them both by x. So we're going to take out a 4x. Then we have a y and a y squared. So here's my y and my y squared. So we're going to take the smallest power between the y's, which is a y to the first. And we're going to divide both pieces by 4xy. So in the first part, the x's and the y's cancel, and we're just doing 8 divided by 4, which is 2. And then in the second part, the 4's cancel and the x's cancel, and we're left with y squared divided by y, so we keep the base, which is y, and subtract the powers. Again, final answer. Okay, why don't you try number 5 on your own, and then hit resume when you're ready for the answer. Okay, so you should have noticed that they're both divisible by 9, and the lowest exponent between the m to the third and the m squared is an m squared. So we're going to divide everything by 9m squared. The 9's cancel. M to the third divided by m squared is m. And everything cancels in this last piece. So anything divided by itself, don't forget, you should have put a 1. All right, just for purposes of time, I'm going to skip number 6. Feel free to try it on your own. And if you want to remind me, we can go over this one in class tomorrow. All right, I'd like to try a question like number 7. I know it looks a little scary at first, but it's really not as bad as it looks. I want you to consider number 7 similar to a problem like this. What if I had XA plus 7A? What is my GCF? Well, you guys should be saying A. So I can divide both pieces by A, and I'm left with, once I cancel out the A's, x plus 7, right? So I want you to consider that this 2x minus 9 is your A, right? And that is your GCF. So I'm going to do the same thing that I know how to do. I'm going to pull out the GCF of 2x minus 9, followed by an open parenthesis, and I'm going to divide each of the pieces by 2x minus 9. So those cancel, and I'm left with x plus 7. And that's it. That would be my final answer. Awesome. Why don't you guys try number 8 on your own? Just a tip here. These two parentheses, x plus 10 and 10 plus x, are actually the same thing. They're just written backwards. So you could rewrite this before you start it as 2x, x plus 10, minus, and it's helpful if you put a 1 in front, and you could rewrite this as x plus 10 because the commutative property of addition says 10 plus x is the same thing as x plus 10. All right, so give this a try and then hit resume when you're ready for the answer. All right, so you should have seen that your GCF was x plus 10. So you want to take out the GCF followed by an open parenthesis, and you're left with 2x, oh, excuse me, and you're dividing by x plus 10 on both sides. And they both cancel, and you're just left with 2x minus 1. So that should be your final answer. All right, so number 9, same thing. The GCF is x minus 4, but notice that there's an x minus 4 and a 4 minus x. That is actually going to work out a little bit differently. So in this one, you can choose to divide either one, the x minus 4 or the 4 minus x, right? Commutative property of addition is only works for addition, not subtraction. So we can't rewrite it. So what I'm going to do is I'm going to divide both sides by x minus 4 and this one by x minus 4. So I have the GCF followed by an open parenthesis. These cancel to 1. Anything divided by itself is 1. And we get x. Now these are actually going to cancel the 4 minus x and the x minus 4. They actually cancel to negative 1 because of that minus sign. So this is actually 3 times negative 1 now, which is negative 3, is what would be left with there. And that's it. That's the final answer. So take a minute and try 10 by yourself, and then hit resume when you're ready for the answer. Okay, so I'm going to divide out an x minus 3 on both sides. These cancel. I have my GCF on the outside, followed by an open parenthesis, and I'm left with 5x. These cancel, but to a negative 1, so 5x minus 1. Final answer. All right, now I'd like to go over factoring using difference of two perfect squares. So a vocabulary review. Difference means to subtract. A perfect square is the result of two of the same numbers being multiplied together. So 1 is a perfect square because it's the result of 1 times 1. So is 4, 9, and 16, so on and so on, right? If we talk about variables, right, x squared is a perfect square because it's the result of x times x. X to the fourth is a perfect square because it's x squared times x squared, right? Remember when we have exponents, we keep the base, which is x, and add the powers. That's how we're getting x to the fourth. Same thing here. We keep the base, add the powers, we get x to the sixth. Same thing here. X to the fourth times x to the fourth, we keep the base, add the power, we get x to the eighth. So when we're solving, we want to make sure we remember to add our exponents, and I want you to just look at a few things. What do you notice about the exponents of all these perfect square variables? X squared, x to the fourth, x to the sixth, x to the eighth, x to the 10th. You should be realizing that they are all multiples of 2. Right? 2, 4, 6, 8, 10, 12, 14, 16, 18, they're all multiples of 2. And then what about its square root or its perfect square, right? What thing times itself gave me x to the fourth? What's the relationship between x to the fourth and this x squared? What's the relationship between x to the sixth and x to the third? X to the eighth and x to the fourth? You should be saying the square root is half of the power. So what in the heck do I mean by all this? Let's do a couple examples and hopefully it'll make more sense. So it says factor each expression completely. So x squared minus x minus 16. So it's a difference of two perfect squares. So the way that we factor these is we do two sets of parentheses. And in the first parenthesis, we're going to put in the front the square root of x squared. Or in other words, what thing times itself gives me x squared? And that is x and x. Then in the back end of the parenthesis, we're going to put the thing that multiplies by itself to give us 16. And you should be thinking 4 and 4. And then we just do a plus and a minus. And that's it. That's my final answer. So number 2, same kind of concept. But because the 16 comes first now, what's going to go first is going to be the number. So the square root of 16 goes in this first end of the parentheses, so 4 and 4. And then in the second back end of the parentheses, we get x and x, right? Because x times x is x squared. And then we have a plus and a minus. So it depends on what comes first. All right, awesome. Let's try one more example. Number 3. We have 5b squared minus 500. Now, a lot of you are probably like, well, they're not perfect squares, so how am I supposed to do factoring of difference of two squares? Well, we have to remember, when I ask you to factor something completely, there could be a GCF. So we actually can take out a 5 out of both of these. So we have 5, these cancel. We are left with b squared minus 500 divided by 5 is 100. So now we've factored out a GCF, and what's left over on the inside is actually a difference of two perfect squares. So we can go ahead and factor this out. The square root of b squared is b and b, that goes in the front. The square root of 100 is 10, and that goes in the back. And then we just do a plus and a minus, and we bring down that 5 in front. And that's it. That is factoring with GCF and dots. All right, I'd like to do just 2 more problems, and then you guys will be on your own to do 6, 7, 8, and 9. So for number 4, we want to go through our factoring rules and say, is there a GCF that I could divide out of both of these? I'm thinking 5, right, because they both end in a 5. So let's go ahead and do that. We take out a 5. We're left with x to the 6th minus 125 divided by 5 is 25, and then y to the 30th. So this one's a little bit harder because we've got these higher exponents. So if you go to the front page, you'll see x to the 3rd times x to the 3rd is x to the 6th. Remember, we add the powers. So what am I going to need to get y to the 30th? We need y to what power and y to what power? So you should be remembering that we have to have it. So half of 30 is 15. So y to the 15th times y to the 15th is y to the 30, because 15 plus 15 is 30. So when I break down x to the 6th, I will get x to the 3rd and x to the 3rd. That's going to be the front half of the parentheses. We'll put our plus and our minus. And how do I break up 25 y to the 30th? Well, the square root of 25 is 5. So we're going to put a 5 here and a 5 here. And the square root of y to the 30th is y to the 15th. And that will go in the back end of the parentheses. And then we just have to remember to bring down the GCF of 5. Okay, last problem is number 5. A to the 4th minus 81. So there is no GCF. So I'm going to actually just go straight to dots because it's a difference of two perfect squares. So the square root of a to the 4th is a squared and a squared. And the square root of 81 is in fact 9. And then don't worry, we need to remember our plus and our minus. So this is an example of double dots. And it's double dots because I actually have another difference of two perfect squares. Here is another difference of two perfect squares. We could break this up into a times a is a squared. 3 times 3 is 9. and then a plus and a minus. And we actually just bring down this a squared plus 9 because we can't do another dots. This is not a difference, right? A difference of two perfect squares can be broken down, but not a sum. This is a sum. So we actually cannot do that. So the answer would be that we can't factor it. And that would be our final answer. All right, I'd like you to try 6, 7, 8, 9 on your own, and then we can go over those in class tomorrow. All right, have a good night.